So lesson for Tuesday, 10-13. We're going to be learning how to write equations for quadratics given 3 points, and we're going to be using a 3-variable system to do that. Now the first thing that we have to do is establish a pattern. So we're going to be looking at NASA can create a weightless environment by flying a plane in a parabolic pattern. It goes up and starts to come back down. So as the time in seconds increases by 5, and notice we are doing a set pattern of going up by 5s, that's important. The height goes up, 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 and then it starts to right around here, go back down. So we see that parabolic pattern. But we need to see if it fits an exact parabolic pattern. So what we're going to do is we're going to find the differences between two consecutive y values. So we're going to find the difference between these two y values. And to do that, we subtract the second value minus the first. So 29,025 minus 26,900 has a difference of 2125. Difference from here to here, what does it go up by? 30,600 minus 29,025 is 1575. Again, subtract these two values would give me 1025. Subtract these two values gives you 475. And then we can keep going along those same lines. Now if I subtract these two, it actually would be negative 75. And we don't have to do all of them. As long as you show me a couple, it's like 2 or 3 of them maybe, then that's sufficient. Now there's no common difference here. They all have different differences. But we are looking for a pattern among those differences. So what I'm going to do again is I'm going to take the difference between these two, and I'm just going to write over top of my words. So I found the difference between the consecutive y values, and now I'm going to look for a difference or a pattern between those. Well, from 2125 down to 1575, it goes down by 550. Same thing here. From this difference to this difference, it goes down by 550. And that's going to continue all the way through. So from here to here, here's my differences not in the chart. It decreases by 550. From here to here, it decreases by 550. Here to here. And because I've found a definitive pattern amongst the differences that I calculated, I have proven that this pattern is quadratic. And I can use this method. Alright, so how are we going to use this method? Once you've confirmed that it's a quadratic pattern, we're going to pick 3 points, and you can really use any 3 points from the chart once you've identified it as a quadratic pattern. And we're going to plug those points into our standard form, y equals ax squared plus bx plus c. So I'm going to use 10, 26,900, the 20 point, and the 30 point. These are the 3 points we're going to use. So I'm going to plug those in. Y equals, so I put the y value first, equals a times x squared, 10 squared, plus b times x, the x value in the point is 10, plus c. And I do that for each point. So the next line, I'm going to have the y value for this point and plug in the x value, so I get x squared and x. And then the third point, the y value, x squared and x. So I'm plugging in the x and y values into the standard form. And what I create is 3 equations that use a, b, and c as its variables. So we rewrite this first equation, 10 squared. Let me get rid of some of this junk. 10 squared is 100a. b times 10, 10b, plus c equals the 26,900. Same thing here. 20 squared, so I have 400. b times 20, 20b, plus c equals that y value. Same thing here, 30 squared is 900, 30b, and we just kind of clean those equations up. So what I've created is a 3-variable system, and I'm going to solve that system using elimination. I can also solve with substitution, but I think that's probably harder. So I'm going to take, let's take a look at those equations together. I'm going to take the first equation. Now, the easy thing to cancel here, remember, let's go back over this, is that you cancel one variable with any 2 equations, so like the first and second equations. Then you cancel the same variable, remember we highlighted that, between another two equations, like I'll do the first and third, and then you'll have a two-variable system. So we're going to cancel C. So then you end up with two AB equations, and then it's just an Algebra 1 problem from there. So I'm going to take the first equation, and I'm going to cancel C because these all match up. I really don't have to do much multiplying. So I'm going to take the first two equations. So here's equation 1, and I'm going to take equation 2 times -1, so I can change those signs. So that's equation 2. I've just changed all three signs, or all four signs, multiplying by -1. And you can see the C's now cancel. I have 100 minus 400, 10 minus 20, and I subtract those numbers, and it gives me this mini equation. And you can use that. I'm going to reduce it because I see each of them could lose a 10. Divide each term by 10 and reduce that equation will make the numbers a little smaller. Can't always do that, but this is definitely a case where I can reduce that equation. And I'm going to take the first equation now and the third equation times -1. So I just change all three signs in the third equation. You can see the C's cancel. 100 minus 900, 10 minus 30, subtract here. And again, I see that 0 can be taken off of each, so divide them all by 10. And I have a reduced equation. Just makes the number smaller. So I'm going to take these two equations and combine them together and solve. So here's my two equations that I just made. And I'm going to take, so it should be pretty easy. I see this b, if I multiply this by -2, will cancel with the other b. Just basic elimination. So I'm going to multiply that top equation by -2. So it gives me positive 60. -1 times -2 is positive 2. -370 times -2 is positive 740. Watch your signs. And then the second equation can just stay like it is. Now I'm ready to combine these. -20a, these cancel. 740 minus 520 is 220. Divide by -20, and I get -11 as my a value. We're going to back substitute now. So if a is -11, I'm going to plug it back into this equation. So -11 goes in for a, giving me positive 330. And when I solve for b, I get 700. And then if I have a and b, I can plug those into one of the original equations that I made, and I can solve for c. So now I know a, b, and c. And if I know a, b, and c, I have my quadratic equation. Y equals a, x squared, plus bx, plus c. And now we have written our quadratic equation. And I know this seems a little long, but this is a method solving with elimination that we discussed earlier this year. So it's something that you should already know how to do. And it is on the first quarter exam on the 23rd. So it's a good idea to start reviewing some of this now. Okay, you can get off and work on the homework. Come back into the live session if you want more of an explanation.